All right, folks. We're back. We're back. All right. So, um, right. So we want to get into doing the action edit delete. What happens in terms of and let me just show it here. I'm going to show it here. At the end of this here, the what guides who we are editing or deleting is guided by this action ID variable, right? So printf, I'm just printing out to show what is coming out here. %sign d, comma, action ID. Okay? So let's do a little testing and see what happens. The action ID should come out inside of 3 asterisks. Let's do a little testing to see what happens when we have different persons. Actually, I need to put a getcha after this, or else it will just jump out. Okay. All right. So we say search for a player. Search by ID. Enter the ID to search for 118. I think was a valid ID. Right. So we saw that one come out, and we see that this is the action ID for when it's a single ID number. So this is good. If we search in, and we search in by name, we have DALR. We have 2 persons coming out. So we want to now select the ID of the person we wish to edit delete. Let's go with 111. That is the action ID we eventually get. What about if we search for a player and it's a single player. It's a single player by name. So we search for EMM. Look at that. It held the previous action ID, right? And if this was the first time that this was running, it would have held garbage. We need to put in code that will make provisions for when we only have one person in that array. And we could easily do that by putting a line here that says, if S underscore R underscore index is equal to 1, then we say that action ID is equal to search results at position 0. If there is only one result returned based on a name search, save that ID for that name as the action ID. So I told you there was 3 lines. It's actually 2 if you don't count the bracket. Okay? So now if I go back and I search for a player and I have name and I say, okay, I'm searching for Emmanuel, the action ID coming up at the bottom is that person's action ID. I'm just curious to see what will happen. What will happen if it is that I have search and name. Sorry. Oh, okay. You see a garbage ID number came up. Right? Well, we'll deal with that a little later because we're good programmers and we love to procrastinate. So at least we know that that action ID is working for most cases where we have people. What do we want to do now? Now we want to say, okay, for the selected person or for the returned person or for the shown person, do I want to edit or delete? And I want to do the delete first because the delete is more fun than the edit. All right? So how do we delete somebody? We know that when we have information in the file, we have information in the file from, so this is the file, and let's say for instance we have ID number 123 NYSSA BALIEY. That's how it's spelled. Right, BAILEY. Right, and she was born the 22nd of the 3rd, 2004, and her position is a left winger. Right, we have this information in the file. We know that we read this information from the file into a struct array. So we know that Nissa's information will be read 1, 2, 3, ... into here, along with anybody else's information, 1, 4, 5, right? ALEXANDRASEEGOBIN, 12 to 2004, right? Right back. We have 145 here. Okay, and all of this information will be read into the array. But now we want to delete information from the array. The way that we have created this program is that when we want to do something, we read everything from the file into the struct array. And then when we're done with the struct array, we write that back to the file. Let's introduce what could be considered to be like an invisible field inside of this struct array that will tell us whether or not to write somebody to the file. You all see where I'm going with this? If I have a field here that says, right, delete my del, and it's called del, and it's a single character, and it could be TOF. And once I load up everybody, it's F, which means don't delete this person, don't delete this person, right? Let's say we had 162, right? ANDRE DAVIS, 13 of the 11th, 2005, striker. We have 162 here. And when we load him in, this gets defaulted to F. We don't want to delete anybody. But we do our search, and we search for Andre, and we find Andre, and they say, what do we want to do with Andre? Well, we want to delete him from the system. We will then turn this tag to true, so that when we send this, or when we call the write file function, if it sees that the delete field in the struct that is loaded in memory is true, what happens? That line does not get written to the file. And that is how we will effectively delete somebody from our file. Does that make sense? Right? They existed when we read them into the file. We say, okay, the delete flag, we mark this player for deletion. So when we write in, essentially we write back 123 ... 145 ... but we don't write 162. And that is because he was carded for deletion. So what is going to happen the next time that I read this file? He's not going to be there. He was deleted from the system. Everybody follow me? Make sense? All right, so are you going to go home and try it on your own? Not even one yes, sir. A little disappointing Kyra, because Kyra in her heart right now wants to go home and try this. And a little discouraging her. Alright? Kyra stopped me in the hall during the break and is like, listen, sir, we need more work on our, on our own. You're spoon feeding us. All right. Nobody say that. So listen, I lying on Kyra. All right. I would admit. I'm lying on Kyra. All right. Because it's Clement who told me that. All right. Clement was the one who said, Clement, you believe in your heart? Clement up for the challenge. The man standing up. All right, well then that's it. We done for the day, right? And we'll spend the rest of the time till 11 working on this on our own. Right? Mister, you was all for that just now. I said we done for the day, and you agreed, but the sentence wasn't finished. The sentence was we done for the day and we working on our own. You're going what? You're going to be verbose in that 162 was not written to the file then? Uh-huh. Yeah, just skip over it automatically. But you're going to have to make some concessions just with this, just like with writing to the file, right? Remember, you have to think about what if the last element in the struct is the one that you're not writing, or if it is that the one that was before the last, because you don't want to skip a value that don't exist. So we, all right, uh, I'm being recorded right now. I can't answer that question. All right, yeah, that we will talk about after I'm finished recording. Let's see how this works. All right, you all have convinced me to show you all how it works, and we'll have a discussion near the end of class. All right, this here is just the concept. You all understand the concept behind how the deletion works. Essentially, it's deletion by omission, right? We tag something as no longer do we want to put this in long-term storage, which is the writing to the file. So that in future, when we say, hey, read the file again, because it wasn't written, it's gone, it's gone. And once you close off the program and the memory gets cleared, it's gone, right? So let's go and check out how we're doing this. So we know that at this point, we could mark who we want to edit or delete or whatever. We could actually put out the statement that says what do you want to do with the record at ID number %sign D. All right, we could say printf. We could say printf one edit to delete. Okay, and then we could have the submenu option, right? Scanf %sign the ampersand sub underscore opt, and put a get char here. We have to declare sub underscore opt. I like to declare all my variables up to the top of the even though it's getting long, sub underscore opt. All right, which is the sub option menu, and we'll do something from there. Okay. Um, or tree cancel, but we'll put in the same verification later to loop it. Okay. You have edit, delete, sub opt. Let's just see. Oh, I just put a space. Thank you. All right. So we search. We have ID 118. We have dollar input on. Essentially, it says, what do we want to do with the record at 118? Edit or delete. And it asks us for this. If it is, we're focusing on delete now. If it is, we want to delete if it is that we want to delete what you call it, the record, we have to have now this struct blueprint. We have to make the change. We have to put in, right, char del delete marker. And by default, delete marker is going to be false. But if in the delete we say, hey, mark this person for deletion, then we put it as true, so that then we could go into the write file function and only write to the file entities that are marked as false. If the delete marker is marked as true, then we don't write them to the file. So the deletion is really and truly less about actually deleting and making just about making sure that they don't get written to the file. Could you say it louder? Yeah, we'll just have it either coded with F or F or T, sorry. Right? So we have to go into the read file function or the read players function where we read from the file. And everybody, when we read them from the file, we're going to say list at position list underscore I dot what? What is the name? What was it that I called it? del underscore marker dot del underscore marker is equal to f. Right? So by default, everyone will be written back to the file because their delete marker is set to F. If I put delete down here and I say, what do you want to do with the record at ID, whatever the ID is, right? And I select 2, delete. I could say now, if what? If sub underscore opt is equal to 2, y'all want to be kind to the user and say, do you really want to delete? Or just mark it as delete. uh, a little believe in mistakes, boy. Lord. One Pennywise treatment. I too kindly. Right. So I'm gonna put out, I'm gonna say oh I'm gonna have to search through the array for that value. I should have just used the index from the jump. But and I was at a question where you were just uh alright. Alright. If the option was equal to 2, I I I am going to give them the pen. I'm not gonna ask them for a confirmation. Right? Right. After deleted. Your player was deleted. Did you really mean to do that? That is evil. Alright. You know what? I would hate to see you guys design cars, boy. Alright? Because that's not. I didn't have like subscription earbags. I hear you. All right, so we have to search through because I would admit that I should have used and recorded the indice of where we wanted to delete rather than the ID number. We are going to have to search through to find out what index this person is at, and then we're going to have to mark them as deleted yes. But that's just a for loop away. All right, so for I is equal to 0, semicolon, I is less than list underscore I, semicolon, I plus plus, right? If list at position, sorry, I dot ID, right? If list is at position I, yeah, dot ID. Let me see. Position I dot ID is equal to, if list of position I dot ID is equal to what did we name it? Action underscore ID, then we will say list at position I dot delete marker is equal to T. Right? So what did I do? Search the array for the ID of the record to be deleted. Right? If the record is found, if the record is found, set the deletion marker to be true, right? And it could break because it's only supposed to have it's only supposed to have one record with that marker. So once you find the marker, you could break, right? And you could say the player will be deleted. All right, the player will be deleted. Backslash n. And I'm just going to run it through and test it. Just to make sure it's not actually going to delete the player because we haven't made the modifications to the write file function. Okay? ID is what? Common? Let's start position I dot del marker is equal to right. Single. Come on, Mr. Valdez. Same thing, single, because it's a single character. Alright. So let's just see. 3. Name DALR 118 2. It did it, but it did not because I didn't have a get char, which I'm now about to put. So we have to do that again. 3, 2, DALR, 118. What do I want to do with the record? I want to delete it. The player will be deleted. Okay? But if we view all players, he's still there. We don't want him there. We want him gone. Huh? Just draw a line through him. That seems like more work to do in C than to just remove him from the file. So what we have to do now is that we have to go to the write file function, write players function, and modify our code so that it only does that fprintf statement for for what you call it, for players whose tag is F. All right. But what I want to do beforehand is I want to go to my drive and just make a backup of this file, because with writing files, you always want to make a backup. Oh, okay, I already had a copy. Yeah, but this copy was kind of crappy. So let's copy and paste that. Save that into the copy so that if I mess up this file here, at least I could just copy it back and continue testing, okay? Without having to write over a data set. All right. So let's just start off with the if we store all the what? The deleted names? What do you mean? Like, well, you could modify it if you want to allow for multiple deletions at a time. I just showing a single deletion here. So you could queue up, you could go into the search and into the search function and allow that search function to queue up and say, okay, if you want to delete more than one name, you could just jump back and forth until you're ready to stop deleting. Huh? Well, yeah, you could write it a different file if you want, but then that's not deletion. Well, yeah, all right. So then that is considered to be more like archiving. So you could give your option to archive, delete, and if you want to archive a player, you could write them to a separate file. That's fine. Again, what I'm showing you here, this is the basis. You could choose to do that with it, right? Because it's just a matter of saying, yeah, that's basically it. Well, why are you also attached to these players who are going to be deleted? What? Just that. Oh my God, no! It just not the file don't need to be named dead. Oh Jesus! It's grim. All right, or we can name it archive to just make it a little softer. All right, Omar. Okay, all right. So let's just start off with the simplest possible thing. We say for every position in the struct array, we would say if what? If list at position, if list at position I dot del marker is equal to, is equal to F, then what do we want to do? We want to write them to the file. Otherwise, don't write them to the file. So let's just check this. I might have to make a concession for certain places, but I'm trying to see if I could get through with the laziest thing possible. All right. So we compile, no errors. We're going to delete. We have to test two places. We have to test within the whole list, and we have to test the last one. Because the last one, of course, had special concession, right? And this is where I'm going to have to put some code inside here. Because if I delete the last one, then technically the second to last one should not write a \n. You all follow me? Watch this. If I have a list of names, if I have a list of names, Hanson, right, Andre, Kyra, right, Tracey or Tracey? Tracey, and Omar, right? Omar is the last name here. And I want, yeah, you can delete it, right? Right? I wanted to take this information. This is my struct information here. And I want to write it back to the file. We know that the rule that we came up with just now, is that if it is, let's say this is position 0, position 1, position 2, position 3, position 4, which means that list underscore I is going to be equal to 5. Guys, it's just a little bit of logic here. It's not hard maths. If it is that I want to remove Omar, it means that I'm writing position 0 and Hanson to the file. I put a \n. All right, Andre to the file. I put a \n. All right, Kyra to the file. I put a \n. All right, Tracy to the file. But should I put a \n here? No. So that means I'm going to have to look ahead. I'm going to have to look ahead to make sure that the next element is not the last element and that it's not set to be deleted. Otherwise, I could write this \n. Because if it is, let's say, for instance, Omar wasn't set to be deleted, we already have code inside there to ensure that, Tracy gets with \n and then Omar doesn't get a \n. But if it is that, right, let's say, for instance, Omar getting deleted, we can't write this \n, or else next time we read this file, there is going to be some sort of error. These are the kind of things we have to look out for, right? So, but let's just see as I have it here how it would work. Okay, so we're searching for a player. 3. Search by ID. 118. Delete. Player will be deleted. If I go to view all players, oh, I still seem to have him here. Right? Let me see if that it actually impacted on the file at all. Right? What? Why did you? Yes. Yeah, go ahead. Yeah, if the delete marker is false, then we're going to print them to the file. But if the delete marker is true, you want them not to print to the file. So when it's F, you're printing them to the file. Let me go and see what foolishness I wrote down here. So if the marker is 2, then we change del marker to T. Right? List at position I dot del marker is equal to T. Yeah. Yes. Yes. In terms of writing it to the file, yes, but action ID in this instance is a local variable in the file. We by default did not set up the file right to accept any parameters. So we could modify the function to accept the action ID, and otherwise if the action ID is -1, we just write everybody. That's another route you could take. So that's a personal thing up to you, right? So I was just changing the delete marker there. Let me just print out. Let me just print out because I am wondering why. I'm wondering why I'm not getting this person to print out, and I need to see them. Printf %d, %s, %s, \n. I like to put my asterisks around these to just let me know that this is something that I'm putting here for default, for debugging purposes. List at position I dot ID, list at position I dot fname, list at position I dot L. Okay, so let me just and let me see %sign C. Let me print out the delete marker too and see what's coming up. List at position I dot del marker. Okay, so it should tell me 3.1.1.1.8 2 1. Okay, so Brendan did get marked for deletion. So this part is working. I know why it didn't work. It didn't work because at the end here, I was supposed to call my right players function, and I did not call the right players function. So, right players. So it didn't work because it wasn't called. All right, so we're going again. Let's see what happens. 3.1.1.8. This is the last person in the list, right? Delete Brendan. Right, so view all players. Now we're getting problems. My program crashed. That's a good thing. That is a good thing because I know now that my file was changed in such a way that, like, as I predicted, I think that we didn't make provisions for that extra hanging indent. And we know that when we have that, our program typically crashes. The \n is there over, and that is what is happening here. We don't have any Dalrympleton inside of the file. We got rid of him, right? Let me just save in. Let's take out Dalrymple normal. Dalrymple we testing here. That's what I said we doing. Let's see what happens when we do it inside the body and it's not the last person. Because the issue that we identified just now was that there is that \n issue with the last person. So we have to go back in the code and make that change. It's an easy change. Don't panic about it. But let's take a look at it. Right? So we fix the file. If we run this, it works. Right? Because we took out the \n. We're going to take out 3, search for a player. Then we say make your selection ID 111 right? We want to get rid of Brandon Dalrymple. To delete. We know that this where this Dalrymple is not in at the end. This is inside. So let's see what happens here. To delete, the player will be deleted. File data written successfully. 2. He's not there, and it worked. So the only issue we have is when we delete somebody who is at the end of the list. It comes back to what we're saying. If you're deleting the person who is at the end, then the person, when we're writing the second to last person, there should not be any \n. We already knew that we have a condition in the write file function. Where is the write file function? Write players function. To not write the \n or to write the \n. We say if it is the last person, don't write the \n. But now we could say or, right? We could put in another thing that says, or if it is that we are on the second to last person, how would we know that this is the second to last person? Coming back to this here, we know that we know that we have a variable that keeps track of how much people is in our array. So if it is that we are on person 3, if it is that we are on person 3, and we see that Omar, person 4, is marked for deletion, right? This is his del marker. If we're on person 3, and this person is supposed to be written, right? Well, even if this one is the one marked for deletion, then this one is fine because it will hold up with our original code to not write the last a \n after the last person. But if it is, we have to come up with a thing that says, okay, if we're on this person 3 and we see that person 4, which is list I -1 -1, right? Sorry, list I -1 is marked for deletion, then we don't want to write that \n. You all follow where I'm coming from? Right? So let's see if we could just think up of a statement that will prevent us from writing this \n here. Right? If list I is equal to the last person, then we write the \n. It says here, this here says if we're not at the last person, then write the \n. Right? And then we have to say also if list I -2, so if list underscore I -2, which will in this case put us on the second to last person, right? If you're on the second to last person and the last person's delete is false, then write the \n. Right? So if list I -2, if list I, -2, and list underscore I -1, sorry, not list underscore I -1, list at list underscore I -1, and the last person dot del marker is equal to F. Then you want to write the \n. If I am on Tracy and I know that Omar is to be written to the file, then I want to put a backslash n. That makes sense? But if I am on Tracy, right? If I'm on Tracy, position 3, and Omar's marker was T, then I don't want to write the backslash n. Because Tracy is now the new last person in this list. Follow me? And then when my I goes up to list I minus 1, it's going to see that Omar is not to be written to the file. So it will skip it, and then it will do the F close, and my file data will be written correctly. So under these circumstances here, right, if list I minus 2 and list I at position list I minus 1 dot del marker is equal to F, then I want to write that data to the file. Let's test this out and see. All right? Or what did I have there? List underscore I minus or I is equal to list underscore I minus 2, right? If I'm on the second to last person, and the last person, list at position list underscore I minus 1 dot del marker is equal to false, then I want to write the backslash n. Should we test this? Of course. Let's test it. The worst it could be is wrong. Right? I mean, you know, what you're gonna do if it's wrong? Sit down for a half hour, cry, think about it, and then try again. I was there, you know. I was there, like where you all are at. Honestly, I was, you know, I I had bouts of depression and all kind of things, just you know, thinking about why this thing not working and whatever. I mean, even as up to as recent as I would say, um, 2 years ago, so when I was doing a course called algorithm analysis, where you have to like write an algorithm to solve a maze and all kind of thing, right? You know what? Well, it don't even have one. It have like 1,000 of them, but yeah, but you know what I hate? I hate when they start off in English and then halfway through they start to talk in Hindi. And it's like, yeah, and the thing is, the Hindi does have like English in between, so like it is be there for at least 3 minutes, like a fool listening. I'd be like, wait, I'm not understanding, not because the topic hard, I'm not understanding because you're not talking English. Yeah, yeah, yeah. Yeah, yeah. And then, huh? The solution is to learn Hindi. Uh, all right. So let's test it and see. Right? So we have view all players. Let's see if we delete in Keon. Keon is record 102. All right. Bye-bye, Keon. ID 102. Keon Smith. Delete. Player will be deleted. All right, let's see view. Oh no, it crashed, which means Keon got deleted, but it still didn't work out the way that we wanted. Oh well, let's try again. Let me put back everybody in. Where did it not work for you, Mr. Valdez? If I is an equal, I think this is supposed to be an and. Right? Let me just switch this to and Brandon Dollar and Fulton 118. Trey Search ID 118. Delete. Oh, it deleted everybody but it deleted everybody but Ola. Alright. Uh, you all want another break? Alright, let's take 5 minutes. I can't say more than 5 minutes because you're gonna take more than 5 minutes.